So good morning students, welcome back. Today we'll discuss one of the most important topic, transformer. Okay, the question arises first of all, what is transformer? So listen the definition: a device that is used for changing the alternating voltage, AC voltage, low to high or high to low, is said to be transformer. Okay, it convert a device, okay, a machine that convert low voltage to high or high voltage to low. It means it is used for changing the alternating voltage only. Alternating voltage, low voltage to high or high voltage to low. Why? Actually, I'll give example. In that main supply, in the switch, there comes 220 volt supply, okay, and at the rate of 50 hertz, okay. But suppose you have to charge the mobile. For mobile, mobile required only 12 to 10 volt. That battery required 10 to 10 volt. So if we provide 220 volt from the main supply, it will be short circuited, it will be blast. Okay. To avoid those conditions, we have to use transformer. Students, in charger there is a transformer. What is the function of the transformer? The main supply comes as 220 volt. Okay. And the transformer in the chargers decreases the voltage 220 to suppose 12 volt. So that type of transformer is said to be step down transformer. There are two types of transformer: step up and step down. As its name, step up transformer increases the voltage and step down transformer decreases the voltage. Okay, so main supply providing 220 volt, but our mobile required only 12 volt, 10 volt. Okay, so for decreasing the voltage, okay, we have to use charger, and in charger there is a device, transformer, that decreases 220 volt to 12 volt. Okay, I will show you. Look students, this is a mobile charger. Okay, don't worry, जब इमरान सर आए हैं तो सिखा के तो जाएंगे. Look students, थोड़ा sacrifice करना पड़ेगा. Look, this is a mobile charger. Okay students, when we bring, look students, I will show you. This is a mobile charger. Okay, now see students, this device, look at students, this device is said to be transformer. Look at students, this is the transformer. You can see this yellow strips divide is called transformer. And what is the function of this transformer? This decreases the 220 volt supply from main switch into 10 to 12 volt. So this is a mobile charger, okay, and this mobile charger having a device that is called transformer. Okay, it is used for changing the alternating voltage, low voltage to high, high voltage to low. If we provide 220 charge to mobile, it will be short circuit, it will be blast. To avoid those conditions, we are using the charger, and this charger having a device C, that is small transformer, that convert high voltage to low. Understood students? On behalf of design, it is mainly divided in two parts: core type or shell type. Actually the transformer is two types, step up and step down, on increasing or decreasing voltage. But on behalf of design, it is of two types: core type or shell type. I'm having both. Look at students, this is transformer. Look, see, this transformer is said to be core type. Okay, this is the example of core type. Primary and secondary are separate, bound on separate shell. See, and this is called shell type. Look students, this is called shell type. So this is the shell type transformer, and this is called core type transformer. Okay students, this is a diagram. I will discuss the construction of the transformer. Look students, a transformer consists of soft iron plates, soft iron core, okay, and there are lots of core plates placed on one another like this. See students, are placed on one another, and all the soft iron core are well insulated from each other in order to minimize the energy loss due to eddy currents and some other losses. Later on we'll discuss about that. So all the soft iron plates core are placed on one another, okay, and are well insulated. Look students, on soft iron core, the coil that is connected with the main supply, that provide the supply, that is connected with AC source, is said to be primary coil, and this is called input circuit. Another coil that is connected with external load resistance, okay, with outer circuit is said to be secondary, is called secondary coil, and it is said to be output circuit. So the primary coil connected with AC supply and secondary coil is connected with external load resistance. Okay, on this soft iron core plate there wound copper wire, copper turns, that is called primary coil, that is called secondary. Both the coils are wound on same soft iron core at different side. Okay, now students, we'll discuss principle of transformer. It is based on the principle of mutual induction. Okay, what is the meaning of mutual induction? This is primary coil and this is secondary coil. Whenever we apply an AC source, it changes the current. When it changes the current, magnetic field around the coil will change, and that also changes the amount of flux, magnetic flux. So whenever we change the amount of current in primary coil, that induces flux and EMF in secondary coil. Whenever we change the amount of current in primary coil, okay, due to that it produces flux and EMF in secondary coil held very close to it. Such phenomenon is said to mutual induction. On this principle it is based. Okay students, we'll start the working part. See students, as soon as when we apply AC source, it changes the current, okay, in primary coil, and whenever we change the amount of current in primary coil, it induces flux, magnetic flux and EMF, okay, in secondary coil, place very close to first one. Okay, this is called mutual induction. On this principle it is based. So for mutual induction, I'm going to apply Faraday's second law. What is Faraday's second law for primary coil? E equals to EP, EMF of primary coil, EP equals to minus NP d phi by dt. Okay, this is Faraday's second law, where EP is EMF of primary coil, NP is the number of turns of primary coil. Okay, equation first. This is for primary. And what will be the EMF for secondary coil? ES equals to minus NS d phi by dt. Okay, where ES is EMF of secondary coil and NS is the number of turns of secondary coil. Look students, for step up transformer, number of turns should be greater in secondary coil. For step up, primary coil having less number of turns and secondary coil having more number of turns. And for step down, primary coil having more number of turns and secondary having less number of turns. Okay, now student, first divide by second. Equation first divide by second. EP divide by ES, left hand divide by left hand, EP by ES. d phi by dt, d phi cancel out, minus to minus cancel out, will get NP upon NS. It means the ratio of EMF of primary and secondary coil is always equals to the ratio of number of turns of primary and secondary coil. So this is our first main equation. Okay. Now students, for an ideal transformer, input power will also is always equals to output power. Input power supply will equals to output power supply for ideal transformer. Okay, we are assuming this, and you know what is the formula of power? P equals to EI. Either P equals to VI. On behalf of that, how can we get the power of input circuit? EMF of input circuit, current of input circuit. EP into IP, ES into IS. EMF of secondary coil, current of secondary coil. EP divided by ES and IS divided by IP. So from third and fourth, what will get? EP upon ES equals to NP upon NS equals to IS upon IP. EMF of primary coil, number of turns of primary coil, current of secondary coil. Okay, so this is our final main equation. Now students, will discuss energy loss in transformer. Okay, sometime what happens students, the very first is copper loss due to primary and secondary coil. Okay, due to the heating of copper wire wound in primary and secondary coil, some energy lost, okay, due to this winding, and this energy loss is given by P equals to I square R. Okay, in order to minimize this loss, this copper loss due to this primary and secondary winding, in order to minimize this copper loss, we have to use thick copper wire of low resistance. Okay, in that condition we can minimize this copper loss. P equals to I square R. Okay, the second is eddy current loss. What happens, students? Due to this AC source, alternating source, we know it produces eddy current in that core, in that soft iron core. Okay, in that shell. This is said to be eddy current loss. Due to this eddy current loss, it leads to loss of energy in the form of heat. Okay, so in order to minimize this eddy current loss, we have to use laminated core. We have to use laminated core. That's why we use this soft iron core that is well insulated, well laminated from each other. Okay.